Did you know that there's an emerging market that could revolutionize how we access and pay for artificial intelligence? The way we currently price artificial intelligence is fundamentally broken. Fixed rates, regardless of demand or specific needs. Now, in this video, I'm going to propose a new system that could save businesses thousands. Those who understand it early will have a massive competitive advantage. I'm Evan Goldstein. I'm a licensed professional engineer and a data scientist. By day, I work with large capital equipment in manufacturing and other facilities to implement AI. And at night, I'm building AI capitalists to talk to the leaders and the thinkers, like you, about navigating this new world of thinking machines. So I was sitting at my workstation, which was a real mess of technical manuals and half-empty coffee mugs, some equipment logs. You probably don't know what a reliability engineer like me actually does all day, so I'll fill you in. I'm basically the person who makes sure that things don't break when they're not supposed to. I spend my days analyzing equipment failures and designing maintenance programs and trying to predict when machines might give up the ghost before they actually do. It's part detective work and it's part data analysis, and it's a lot of practical problem solving. Anyway, I was deep in the trenches of a reliability monitoring system that I'd been building during off hours for months. I was using language models to do something pretty cool. I was teaching AI to read through thousands of technician comments that they'd made on work tasks that usually just get ignored, thrown on the pile in our maintenance database. Stuff like pump making weird is fine, or I had to hit the reset button twice. Gold mines of information that nobody has time to sift through manually. Now with large language models, we can. But I was also using the system to tackle a constant flood of equipment alarms that plague every industrial plant. We get thousands of those warnings every day across plant, temperature slightly high, pressure low, flow rate fluctuating. And we had no way of telling which ones actually mattered and which ones were just crying wolf. Now my system was working beautifully at separating the urgent signals from the noise. And I just wrapped up testing the predictive algorithms, and the AI was performing very well. Compressor failure imminent, schedule replacement within 72 hours, perfect timing. Heat exchanger fouling detected. It was catching the things I need to catch, but I could already imagine the system deployed across our facility, preventing those middle of the night emergency calls. But then I checked my API usage dashboard. That's APIs are when you write software and it calls into a large language model instead of going through the website, right? It's sending in the information and it's getting the call back. But my excitement evaporated. In just 24 hours of field testing, 24 hours, I'd been through half of my monthly allocation for the model. Not from any unusual spike in equipment data, but because each data point I processed cost exactly the same, regardless of whether I was running a full plant simulation or just checking a single valve. This just isn't a viable long-term solution, I thought to myself. Why does using AI for industrial reliability feel like paying premium rates for round-the-clock monitoring when I only need occasional diagnostics? I also don't need them instantly. When you're sitting there typing and entering things into a language model and getting it back, you're demanding the highest of the high-level AI, right? The fast, instant attention. And as I'm going to cover in a later episode, that actually gobbles up a lot of the processing power. Which for me, if I do it now, I can do it 5 minutes, an hour from now. I don't care. So I seriously considered abandoning the project and heading home. But as a reliability engineer working with tight departmental budgets, the potential for a flexible pricing model could work really well in my situation. During quiet testing phases with just a handful of sensors at 2 a.m., I could access a more affordable model that's perfectly adequate for basic fault detection, and it would keep my project costs manageable. This would let me refine my algorithms and test different approaches without constantly watching the billing meter running up a huge fortune. I could run more simulations, and I could develop a more robust system without the financial pressure forcing me to rush or cut corners. Now, the ability to scale costs with actual usage would make innovation more accessible for engineers like me who don't have unlimited resources. So just that got me thinking, and it gave me kind of an idea. What if the pricing for AI tokens didn't have to be so set in stone? Instead of fixed prices, we could treat large language model tokens like something that you could trade on a market, where prices go up and down like oil or electricity. It was like a shot of espresso, right, for my brain. Maybe it's not the price that's the real issue, it's how inflexible it is. So let's get into this more. If you've ever tried using a large language model for anything, for chatbots, writing tools, or just tinkering around, you've likely hit this wall. The pricing strategy is totally generic. Every provider out there, like OpenAI, Anthropic, or Grok, sticks to a flat rate for every token that you send in through an API call. An API call is just having the software that you wrote call up and ask the AI question, or make an image instead of typing it directly into the website. It's just pretty straightforward. It's X number of cents for 1,000 token, no hidden fees. But that's exactly where it gets annoying. For someone like me working as a reliability engineer on a tight maintenance budget, it's a constant financial drain. I'm checking vibration data on a quiet Tuesday afternoon or analyzing a failed component, but I'm paying the same AI rates as if I were monitoring our entire facility during peak hours. And it's maddening. There's no flexibility, no chance to save money or to load shift from the perspective of the data centers where this work is being done. It's like the old electricity contract before we switched to demand response billing. We're paying premium rates for 24/7, whether we were running the entire facility or the facility was completely idle on a holiday weekend. So how am I supposed to innovate when every little test costs me the same amount as a full-scale deployment? A lot of utilities and cloud services, by contrast, offer variable rates of bulk discounts. Electricity providers often charge less at off-peak hours, and I've worked on projects as a mechanical engineer where we would have 2 reservoirs, and at 2 a.m. when electricity was cheap because everybody's asleep and no one had the power on, we would pump the water up to the higher reservoir, and then when electricity was super expensive at 2 p.m., we would run the water back down through the dam to generate hydroelectric power at the higher price. Even though there's efficiency losses, still paid for itself, right? Cloud giants like Amazon Web Services give steep discounts, up to 90% for flexible spot pricing. These mechanisms let savvy users save money during low demand, which is impossible with flat AI pricing. Now we're having this data center crisis where we just have nowhere to do all the computation necessary for artificial intelligence calculations. You would think that distributing the load across the day, across 24-hour cycle, across 365 days in a year, would result in less need for power generation and less need for data centers. So even big businesses with massive AI setups, like those customer service chatbots or content sites, are in the same boat. They can't tweak prices based on when it is or what the market's feeling. And the AI providers are basically throwing darts in the dark, trying to figure out pricing to cover their server bills and make a few bucks. When demand drops, they're too pricey. When things heat up, they might not ramp up in time. The whole system is a mess, and it leaves everyone just making do. Now, in practice, the static pricing model deters efficient usage and innovation. The cloud computing industry faced similar challenges until it embraced flexible models. Heavy cloud users today leverage things like reserved capacity and spot markets to optimize costs. Without dynamic pricing, AI utilization stays suboptimal for consumers and providers. So I started thinking, why not shake things up? And let's just imagine that we could create a marketplace for AI models where prices change in real time, depending on supply and demand and how well they perform. Here's the idea. We could take a page from other sectors. A commodity market is where things like corn or oil or even energy is swapped around based on how much there is, who's buying, and the quality. Why not apply that concept to AI? Here's how I think the market approach would actually work. AI providers could create detailed profiles of their models, just like we have spec sheets for, let's say, different types of crude oil coming from different places. Each model would show exactly what it's good at, how quickly it processes data, and the accuracy ratings for different tasks. One might be fantastic at analyzing vibration patterns, but mediocre at actually understanding the language of technician notes. So users like me would then get to choose the models based on what we actually need at that moment. It's like how I pick different tools depending on the job. I might use a basic budget-friendly model for initial data screening on routine equipment checks, but then switch to a premium one for investigating a weird noise coming from $1 million turbine that's threatening to shut down production. The best part is that prices would fluctuate based on real-time supply and demand, just like the energy market. I could actually save up all my calculations and then program them to be sent in at midnight, 2 a.m., which would be perfect for running the massive historical analyses that I've been putting off because they're too expensive during the day. Just like how we schedule energy-intensive operations during off-peak hours to keep our utility costs under control. It's not as far-fetched as it sounds. Exchanges exist today for computing resources. Decentralized GPU marketplaces like Vast.ai already let individuals and data centers rent out GPU time at competitive rates. A lot of sellers list their hardware and adjust their prices to attract buyers, just like our theoretical AI model exchange. Even major clouds could have multi-tier markets. So Amazon effectively auctions off computing power to the highest bidder. And we also see early hints of AI services that are introducing batch inference mode that's 50% cheaper than real-time calls. In other words, they're already starting to adopt this method within the large language model providers like Amazon, where you can send in your calculations and your whatever you need them to do, your prompts, and then you just wait to get the answers back when they'll run it when they want to run it, and then you get a discount. Now, these examples show that a real-time market for AI resources is within reach in spirit, but it's not in full form. The marketplace would work like your electric bill, where you're paying different rates depending on when you run your dishwasher. So before I get too carried away, I'm going to go through some of the downsides here. First, you have the apples and oranges problem, right? You know that when you're shopping for a new wrench set, some of them are perfect for precision work and others are better for heavy-duty tasks. Now, AI models are similar. They're built for different jobs. Some are good at understanding maintenance logs, some are good at coding. Others are good at image recognition, but they can't do text analysis. Now, to fix this, I'm thinking that we need something like what Consumer Reports does for appliances. It would have a dashboard that shows exactly what each model is good at. So maybe this one's rated for 5 stars for writing, but 2 stars for image recognition. And that way, when I'm looking for a model to predict bearing failures, I'm not accidentally buying one that's optimized for inventory management. Now, let's suppose that I switched models mid-analysis and suddenly my system went from saying this equipment needs immediate attention to everything looks fine, just because a new model had been brought in with different thresholds. It would be like having 2 different mechanics inspecting your car, with one saying you need new brakes and the other saying you're fine for another 10,000 miles. My thought is we could create a sort of handover protocol. When you switch models, there'd be a buffer period where the new model gets up to speed on what the old one was doing. Or maybe you could lock in a specific model for certain critical workflows, like how we always use the same calibrated tools for safety critical measurements with no substitutions allowed. Now, let's suppose that I've carefully budgeted for the month, allocating exactly what I need for my reliability system, and suddenly prices spike because some big tech company is running massive tests. My budget's blown and my boss is giving me that look then, right? So to avoid this nightmare, we could borrow from how people handle utility bills, maybe offer fixed rate plans for those who need predictability. We're starting to talk about a futures market where you could lock in a rate early so that you could predict and maintain your budget. We could allow people to pre-purchase tokens at today's prices for future use. So I'll admit that I'd be tempted to buy dirt cheap AI options, but in reliability engineering, using a lousy model could mean missing a critical failure that shuts down production for days. Now, that cheap model suddenly becomes very expensive when you look at it like that, right? So one thing we would have to do would be to establish minimum quality standards. Models would need to pass basic benchmarks to even be listed on the marketplace. Like how the cheapest car in the lot still has to pass basic government safety inspections. There's a minimum bar that protects consumers from truly dangerous products. In my world of industrial safety, we have strict protocols that can't be compromised. Now, I can only imagine how much stricter things must be in healthcare or aviation. For these cases, we need a certification system, models that have been vetted and approved for specific regulated applications. These would be clearly marked, and systems in these sectors would only be limited to using these approved models. It's similar to how we have special intrinsically safe equipment for hazardous environments. It costs more, but won't cause an explosion. I'm still working through these kinks in my head. The idea isn't perfect, but neither was the first predictive maintenance system, right? And we refined that until it worked. So sometimes you just got to start somewhere. Now, these challenges resemble those in traditional commodity exchange markets, the need for standard benchmarks, echo how commodity exchanges grade products like wheat by quality or electricity by reliability, so that traders know what they're buying. One other advantage here, by the way, is that if you wanted a startup player who maybe thought that he could figure out a way to provide intelligence, computing power coupled with language model intelligence for a fraction of the cost, he would know what benchmarks he needed to meet and what a good price would be to break into the market. So the specter of price volatility is why commodities have futures and options, so the markets can hedge risk, and ensuring quality and compliance has parallels in other industries too. Now, this would force AI providers to compete on value instead of just prestige and benchmarks. And if you feel you're getting value from this episode, I'd appreciate it if you'd push the like button. Pressing like lets me know I'm making content you want. Pressing like lets me know I'm making content you want to see, and it spreads that value to others. Thank you for supporting AI capitalists. Look at what happened with Japanese cars when they entered the American market, and suddenly quality and efficiency mattered more than chrome and horsepower. They'd build models that do more with less computing power, driving down both costs and energy consumption. I think about our factory's efforts to flatten out electricity usage, running certain operations during nights and weekends when rates are lower. AI could follow the same pattern, and it could shift intense computing tasks to when the grid has excess capacity. Right now, even when multiple companies offer the exact same model, the prices can differ wildly. One analysis found that serving an open source large language model like Llama 2 can cost 10 times more with one cloud vendor than with another, even though it's the same underlying model. These disparities persist only because the market is inefficient. In a true commodity style exchange, we'd expect those gaps to shrink, like how gasoline prices only vary marginally between stations selling the same fuel. Leveling the playing field like this would undercut one provider's monopoly advantage. The competitive jolt would be real. We're already seeing providers slash prices and optimize due to competition. OpenAI, for example, cut GPT-4's cost by over 80% within a year of its launch, figure 3, and it's pressured by its rivals and its newer models. A dynamic marketplace would double down that pressure. If you can run a model cheaper and more efficiently, you can immediately offer a lower price and grab market share. It's hard to imagine a bigger incentive for innovation in model trading and hardware. And then we got to think about sustainability. Data centers today often run servers at only 10 to 20% utilization on average, but they burn electricity even when computing power isn't fully used. A flexible market that ramps up AI workloads or ramps them down with demand would mean less time with the machine sitting idle at full power. Basically, we'd be doing more computing with the same energy. You're going to end up with a lot of side businesses going because of this. You might have AI brokers out there who sniff out the best deals or platforms, and they pull together models just for specific things like teaching or gaming. It could turn AI into this lively marketplace instead of just plain old like a store. This isn't some slick pitch. It's more like late night ramblings that hit me after staring at an expensive API bill. But I can't shake the thought that turning large language models into a commodity market might really turn AI development on its head. So what do you think? Could this work, or am I just way off base? What am I missing? Drop a comment.